Hello and welcome back to another chemistry tutorial with me, Miss T. Today we are looking at stoichiometric relationships, so calculations using balanced symbol equations. This is covered in A-level chemistry across all exam specifications and exam boards, and also IB topic 1, which means SL and HL. As usual, we'll start with some definitions, go through some worked examples, and then finish up with some practice questions. So first, when we're given a balanced symbol equation, it tells us the ratio in which the reactants react and the products are formed. And the coefficients, so our lowercase letters in red, tell us these ratios. So that's the stoichiometric relationship. So in our last few videos, we've been calculating the moles if we're given the mass, if we're dealing with solutions, and most recently, when we are dealing with gases. So if we can calculate the moles, then we can use the balanced symbol equation to find the ratio and therefore the moles of the other species that we care about, and then whatever quantity it is that we need to calculate from there. So when in doubt, find the moles. So for our first question, dealing exclusively with masses, 47.6 grams of ammonia reacted in excess HCl, calculate the mass of NH4Cl produced. So we'll start by calculating the moles of ammonia, as that's what we have the mass for, and moles equals mass over MR, and that gives us 2.8 moles of ammonia. Now, looking at the balanced symbol equation, we can see that the ratio between the ammonia and the ammonium chloride is a 1-to-1 ratio. So that means that the number of moles of our ammonium chloride is going to be the same as the number of moles of our ammonia. So now to find the mass of our ammonium chloride, moles times MR, and that gives us a value of 150 grams. For our next question, let's start mixing up our moles calculations a bit. So we've got what volume of 0.150 mole per dm cubed HCl is needed to completely react with 34.7 grams of calcium carbonate. Well, in this case, we've got enough information for the calcium carbonate to calculate the moles as mass over MR, which gives us 0.0347 moles. Our next step always is to look at the coefficients in the balanced symbol equation to tell us the ratio. And we can see that the ratio of calcium carbonate to HCl is a 1-to-2 ratio. 1 calcium carbonate for every 2 HCl. So our moles of HCl is our number of moles of calcium carbonate multiplied by 2, which is 0.0694 moles. Our final step is to calculate the volume. Volume equals moles divided by concentration, and so that gives us 0.463 decimeters cubed. So 3 significant figures, as that's the number of significant figures we've got in the question. So now our last worked example, making sure that we're really confident using all of the different moles calculations. What volume of hydrogen gas is produced when 30 centimeters cubed of 0.20 moles per dm cubed nitric acid reacts with excess magnesium at 300 Kelvin and 101 kilopascals? So at this stage, we have got the volume and the concentration for the nitric acid, so we can calculate the moles for that. Concentration times volume gives us 6 times 10 to the minus 3 moles. We then use our balanced symbol equation for the ratios. The ratio of HNO3 to hydrogen gas is a 2-to-1 ratio. So our moles of hydrogen gas are 3 times 10 to the minus 3. And now, in order to find the volume of the hydrogen gas, we need to use the ideal gas equation, PV equals nRT, rearranging to make V the subject rather, so volume equals nRT over P. We always take a moment to make sure that our quantities are in the correct units. So in this case, we would have had to multiply our pressure, 101 kilopascals, by 1,000 to turn it into pascals. We end up with a volume of 7.4 times 10 to the minus 5 meters cubed. If we wanted to convert that into centimeters cubed, we would multiply that by 10 to the 6. So now it's your turn. All of the relative atomic mass values that you need from the A-level periodic tables are over to the right. Pause the video now and then press play when you're ready to go through the answers. So for our first question, what mass of carbon dioxide is produced when 4.60 grams of butene is burnt? So we are given the mass of butene, so we can calculate the moles as mass over mR, which gives us 0.082 moles of butene. We then use the balance symbol equation to determine the ratio. The moles of butene to carbon dioxide, the ratio is 1 to 4. So our moles of carbon dioxide are 4 times 0.082. Now to find the mass of carbon dioxide, mass equals moles times mR. So that gives us a mass of 14.5 grams. Again, answer to 3 significant figures, as that's the least number of significant figures in the question. Next, what volume of 5.00 moles per dm cubed HCl is required to neutralize 15.0 kilograms of CaCO3? So we're given enough information for the calcium carbonate, the CaCO3, to calculate the moles as mass over mR, making sure that we first convert our mass to grams by multiplying by 1,000. Then we use the ratios in the balance symbol equation, and we see the ratio of calcium carbonate to HCl is 1 to 2. So our moles of HCl is 2 times the moles of the calcium carbonate, so 300 moles. Finally, to calculate the volume, volume equals moles divided by concentration, and that gives us 60 decimeters cubed. For our last question, a bit more involved, what volume of O2 is produced when 4.00 grams of lead-2 nitrate decomposes at 35 degrees C and 101 kilopascals? So we're given the mass for the lead nitrate, so we can calculate the moles for that as mass over mR, which gives us 0.0111 moles. Then, using the ratios and balance symbol equation, the ratio of the lead nitrate to the oxygen is 2 to 1. So we divide the number of moles of the lead nitrate by 2 to get our moles of oxygen. Now, finally, to find the volume of oxygen, we're going to need our ideal gas equation rearranged to make volume the subject. So volume equals nRT over P. N and R we don't need to convert, but we need to double check that our temperature and our pressure are both in the correct units. So temperature needs to be in Kelvin, so we'll add 273 to the temperature in degrees C. And pressure needs to be in pascals, so we'll multiply our kilopascals by 1,000. Now plugging those numbers in, we get a volume of 1.53 times 10 to the minus 4 meters cubed. So how did you do? Let me know down in the comments, and if there are any topics that you really want a mini tutorial on, make sure that you write them down there as well. See you next time. Bye.